Well, it is my great privilege and pleasure to introduce and welcome our next keynote speaker, Brad Genereaux, who is the global lead for healthcare alliances at NVIDIA, where he focuses on advancing artificial intelligence and deep learning, visualization, analytics in the domains of medical imaging and smart hospitals. Brad is a longtime champion of both interoperability and innovation. He's a friend of FHIR, having been a frequent presenter here at DevDays. In fact, I can remember actually at Brad presenting on DICOM and FHIR at the first DevDays I attended back in 2017. He's also served as co-chair of imaging integration for HL7, as well as DICOM work groups 20 and 27, and serving as the overall chair of DICOM standard committee as well. But today, he's ready to dive into a topic influencing and advancing both the present and the future, firing up AI. Please give a warm DevDays welcome to Brad.
Thank you so much. Yeah. Good morning, everybody. That is so kind. Thank you so much. I am so thrilled to be here. To be talking to you all about something that's very important to me, I think important to the entire world, on artificial intelligence and how we can help transform what our hospitals, what our caregivers, what our doctors, what our nurses, transform their experience and leverage the best and brightest of deriving insights, helping patients and their families in their journeys in healthcare. So a little bit, I think you covered it. My day job is at NVIDIA, where I do developer relations. I'll talk about that in a little bit. I've been involved in the community. I helped create the imaging study resource on FHIR as part of my work in HL7 imaging integration, involved in creating DICOM Web, the RESTful standard for interacting with medical images. I'm currently the co-chair of IHE Radiology Planning Committee, so I'm very much involved in how we profile standards like HL7 and DICOM and others. I teach, and my background actually comes from both a mix of hospital IT experience as well as time in the medical imaging vendor space before I joined NVIDIA. My first experience in HL7 was back in, I'm going to date myself, 2001 or 2002, where I worked at the Ottawa Regional Cancer Center, and our doctors there and nurses had a 23-step process in order to get their lab values. They had to telnet to a session, they had to log in, they had to do all these things just to see the lab work to be able to decide whether a patient can receive chemotherapy that day. And I remember when we invited a partner who said, we've got this great microservice that allows us to talk with the lab systems. It's called HL7, and we actually use that to transform the way that we are able to get this information to our nurses, and it's been phenomenal ever since. If you want to find me, I'm Integrator BRAD on LinkedIn and on Twitter, if you go there. And yeah, let's jump into it. So I'm going to give you just a bit of an overview of how generative AI is changing the world in the healthcare space. I'll talk about some of the use cases that we see. I actually walk through connecting FHIR to generative AI and one of the really neat things that we're seeing. We're really at the industrialization phase of using large language models in our applications. And really the key there is around APIs and microservices and connecting these worlds together. And I'll talk a little bit about at the very end how NVIDIA is helping with that and creating those microservices. So, and if you don't know NVIDIA, most people recognize it for gaming systems. With the rise of deep learning and parallel computation, it's used all across healthcare today. Whether it's post-processing on CTs and MRIs, or helping us find new drugs, or understanding the human genome. In my world of medical imaging, being able to see things with computer vision, NVIDIA's been very active in the healthcare space. So when we look at the impact of generative AI, I think back, 5, 6, 7, 10 years ago even, I remember taking part in some, it was the Cleveland Medical Hackathon, and we were looking at how do we did a hacking project on reducing patient no-shows. And a lot of that is just knobs and dials, and we're looking at tabular data and making predictions based on that data. But it was really focused on really just writing, for loops and if-then statements, lots of them, to be able to, hey, here's who we should sign up for an Uber to get them to the hospital to get treatment. We saw the rise of deep learning across all of our different spaces, whether that, again, my world of medical imaging, to be able to see strokes and cancers and pneumonias in the medical imaging space, but also we use deep learning to make predictions on, a great example was sepsis prediction. So looking at the healthcare data and trying to predict if a patient is going to crash in 4 to 8 hours by looking at their vitals that are coming off of HL7 feeds and training up models to help us with that. Now we see generative AI really overtaking and overshadowing all of the work that we've done in the past. There's still roles for predictive analytics. There's still roles for deep learning. But what we're able to do now is start to understand this unstructured data and put structure to it. We can use generative AI to help us create clinical notes. So there's fantastic examples of, you have a microphone in a room and the doctor and patient has an interaction, and we summarize that and put it into the electronic chart using, ORM messages. We've got, and of course, FHIR message. We've got being able to call the patients and having a conversation with them and ask if they have any questions, all without having to take very busy nurses calling up people and only 30% of the patients are answering at any given time to be able to follow up on surgeries and things like that. So we're really seeing this take off, and it's mind-blowing. Every week we see a new compelling application that is going to change the face of how we see healthcare today. We see this kind of across the board. I'm focusing on digital health today. But there's also a whole space on digital biology as well. And it's, for me, again, mind-blowing. What we've done in this space is if we say large language models is understanding English, French, Spanish, Dutch, if we take that same structure and say, well, what if we looked at the language of proteins and the language of molecules? Can we do the same kinds of inferences to help us with things like drug design and say, here is a COVID spike protein, how do we counteract that? And can we use large language models to help us with that? And it turns out, absolutely. But we're seeing, it's a $10 trillion industry. We're seeing a ton of work happening in the digital health space. And the journey has been really interesting. So back in 2022 is where it really started to take off, where we started to see transformers just taking the world by storm. And when I was at HIMSS, it was like 4 or 5 months afterwards, everybody had some kind of chat GPT type solution. And it was really fascinating because you could see the old school ways of interacting with data and a whole new swath of companies coming in and showing what the impact could be. 2023 was really the experimentation phase where we started to see these foundational models coming together, like Llama, like Mistral, like Gemma, and really kind of galvanizing what that looks like to really prepare us for what we see in 2024, which is all around the production scale of incorporating these models into solutions that are going to be touching the lives of physicians, of nurses, of patients. And what we found is generative AI can take all kinds of data, whether it's textual data, whether it's imaging data, whether it's video data, whether it's things like proteins and molecules, looking at metadata, looking at speech, and pulling all of those things together into something that's meaningful and interactive. It's crazy. I'm going to show you a few examples of what I've done just in the last couple of days with a Llama 3 model and working with FHIR. So I took right off of the HL7 website this example JSON of an allergy, it was an allergy. And you could grab it there. That patient in that example message, the patient is allergic to cashews. And so I typed in this API, given this message, what is the patient allergic to? By the way, later today I will be doing a tutorial, a hands-on tutorial, where we'll actually do this live in the class, and anyone who comes can also do it. It's super fun to experiment with this. But when I asked it this, and I just kind of truncated this a little bit, but this is almost word for word what it came back and told me. I just cut out words. It said, according to that message, the patient is allergic to cashews. It looked at the code. It looked at SNOMED and made that connection and said, this is what Brad is asking about. And it actually provided contextually, based on the question I was asking, the answer that I was looking for. But what's really compelling is that I can actually start to have a conversation about this FHIR message. I asked it, what happens if the patient has cashews? And in that FHIR message, it actually went through and said that they went into an anaphylactic shock, and they actually also get hives. So both of those things are in there. What's really interesting is that the model is actually providing the evidence, so it's not like I'm just getting an answer that I don't know where it's coming from. It's actually saying, based on this evidence of what's in the FHIR message, this patient reports that they have anaphylactic shock if they get cashews. And then I went further and kind of veered away from the FHIR message. Well, what happens if they ate cashews? And that was just my question. What if they had cashews? And I said, you need to give them epinephrine. You need to get them, call emergency services. If they need oxygen, monitor their vital signs, get them to the hospital, notify their physician. It actually gave, again, contextual information for my patient based on that FHIR message, something that's entirely relevant. And I continue to kind of play around with it, like when did they first, exhibit this? And it was back in 2011, according to the FHIR message. Really, really interesting stuff. So that was that. I did another one using the diagnostic report. It was a radiology report of I think it was, well, here, I'll see. It was osteoporosis in that space, that particular diagnostic report. And so I said, well, what is the diagnosis for my patient? And it went through, it pulled that out of the report, told me what the patient had, and also kind of details around it in terms of what is the probability that they're going to have fractures in the future. So I started asking questions like, well, what should I do next for my patient? And it said, well, based on that FHIR message, based on that diagnostic report, here are things that we could potentially do for my patient. Encourage lifestyle modification, consider a couple of different medications and why, how to follow up for them, talk about fall prevention. And one of the things that's really important is that a lot of this is providing guardrails. So that it's not going to, tell me this is the diagnosis, this is what it is. It's going to, properly communicate this information in a safe manner for me to consume, and not like, I saw recently about things like, in order to have your cheese stay on your pizza, you should consider using glue. That was one of the other large language models. It was really fun. So the guardrails in this entire platform is super, super important. The last thing I did, I went about it the opposite way, which is give me an HL7 message. So I'd like a diagnostic report for my patient, John Smith, who just had a chest x-ray done, and the exam showed positive for pneumonia. And it went ahead and created a FHIR message. It's not exactly compliant because there's R4 and R5 and R3 and things like this. There's been slight changes in the resources, but it did a fairly good job of constructing that FHIR message for me. And I've been doing this. It's just a lot of fun. I was like, give me a patient message for Oscar the Grouch, and he lives on 123 Sesame Street. It actually did and thought about what kinds of sample data would I want to see in my FHIR message. It actually does that, which was pretty mind-blowing. So, and then at the very end, it just says, it gives me that disclaimer again, saying, hey, this is one way to represent it, but depending on what you're actually doing, it might look a little bit different. So, again, guardrails are super important. So, I started out by talking about, my experience in HL7 started with microservices back at the Ottawa Cancer Centre. And what's really fascinating is the way that the world has, pivoted back to leveraging microservices to be able to consume this. When we think about the way that we connect these services, and you say, well, how do I start with a large language model? How do I train that? What about regs? What about, kind of all these things? As a developer, these are things that I should be able to consume from whatever service that I want. That I shouldn't have to necessarily be a large language model expert. I should understand, the limitations, the permutations, the types of things, but I really, as a consumer of APIs, I should be able to pass in something and get a response back. So that's something that the industry has been building towards, something that NVIDIA has been working towards. We've been working on inference microservices, and that's what I'll be showing later today in the tutorial, but really just how do we construct these things that are really easy to consume when I'm building out my FHIR applications? As a RESTful API, pass something out, get a response back, and be able to leverage that in whatever application I'm wanting to present, whether it's understanding or simplifying diagnostic reports, or summarizing the patient record, or enabling patients to talk about what medications they're on, contraindications, all of those things. Being able to leverage something that I can pass in a question or pass in, FHIR messages and get back something that is usable in terms of my experience. So the platform that we do, it's really fun to play around with at ai.nvidia.com. If you have your laptop, you can go in. You don't even have to create an account or sign in. You can start to play around with different models like Meta Llama or Google Gemma, or the Mistral suite of libraries. There's coding libraries, but it's just an experience that you can go and see how you could leverage these things as the journey to building large language models into your applications. So super easy to get started, and really powerful in terms of how I might run this. And one of the things that's really important is where you need to be able to run these wherever your applications are, whether it's on your cloud, whatever cloud, or in your data center, or on a device, or on a laptop, and really being able to have that flexibility is super important. So I talked about generative AI, how it's changing the world. I talked about the use cases and how API services and microservices can help supercharge healthcare applications of all persuasions. If you'd like to, chat about it, I don't think we're gonna have time for questions this morning, but you can come find me at the fireplace over there in the corner later this morning. I'll be hanging out there. You can come to the hands-on session, Invoking AI Microservices with FHIR. That's at 2:30. What I'll be doing is walking through creating a drug company using the power of microservices. And I'll walk you through understanding how to treat liver cancer, creating a liver cancer drug. We'll talk about how to, with clinical trials, identify livers in imaging studies. We'll talk about creating promotional images for my new liver cancer drug. And this is all synthetic use cases, obviously not cleared by any regulatory bodies. And we'll talk about the impact of connecting FHIR messages. So everything that you saw on my slides this morning, we'll actually step through doing those in real time, grabbing messages off of the HL7 FHIR website and running those inferences and just interrogating it and asking questions. So it'll be super fun, super lightweight. All you need is a laptop. You don't need any software. You don't need to log into anything, just a browser, probably Chrome, that's what I use. And we'll do some great large language model stuff. So with that, I don't think we'll do Q&A. If you have feedback, please absolutely use that. Use the Whova app. We've got polls. I'm now in third place for the social. I got to get my points up. But do reach out there as well. Yeah, thank you so much.
Well, that was a wonderful talk. Just before you head off to your next sessions, I have one key announcement to make, which is that The buses that will take you from here to the social event tonight will be leaving at 6 o'clock p.m. So buses here, 6 p.m. for the social event. With that, let's give another round of applause and thanks to Brad for that keynote.
Thank you so much.
All right, have a great Dev Days.